Hello, good morning everybody. My name is Emmanuel Nebeli and I'm here once again from Web3Vlog Academy, sharing my knowledge from last week, what I learned, what I gathered, the new things I now know, which has been so exciting. We did quite a lot. Our mentor Vura was quite wonderful. Like, I really enjoyed our sessions and everything. She made sure that she carried everybody along. She didn't do it like she was so perfect at this. She just wanted us to learn from each other, which was wonderful. I just love the technique of teaching. We looked through a lot of smart contracts. We read through a lot of smart contracts. We created a lot of smart contracts. We created smart contract for token, yes, for staking, and also for grants. Today, I am just going to be touching on one of the contracts we worked on last week, which was creating a grant. The basic idea is that, okay, I can create a grant for people. Like, it's just like when you're trying to help people, you create a grant for them. I can also set the time I want them to be able to withdraw that grant. So, with no further ado, I'll go on to my smart contracts. Like, last week was wonderful, so wonderful. Okay, let me get to my smart contract now. Yeah, so this is my smart contract. We are still currently using Remix because we are trying to take it slowly. We don't just move on to other Foundry and the likes. So we are still working with Remix, getting used to the inner workings of Remix and getting comfortable before we move on to something else. Okay, so I already deployed this contract because I was just testing some things out in it. So I'm going to delete it because I want to redeploy again. And take notes. Okay, don't worry about that one. So I want to redeploy again. So I have deleted. Okay, I've made so many notes because I don't want to lose guard. I want to learn this stuff well. Okay, so we are at VOT. Okay, so this is where we created a contract for grant. So the basic idea, a contract where the owner creates a grant for a beneficiary, allows beneficiary to withdraw only when time elapsed, yes, allows owner to withdraw before the time elapsed, gets information of the beneficiary, then amount of ethers in the smart contracts. So this is the basic structure. Okay, don't mind this address I was putting here. I was just using this one to test for a grant I was creating. Yeah. I was using to test for a grant I was creating. So let me just remove this guy first. Now we have our state variables because in Solidity you always have to, when you are writing your smart contract, you solely have state variables that you can modify, you can edit and the likes. So we have address, which is a state variable, and we are setting it to grants, partly withdrawn, because in this our grants that I'm creating, we want to make sure that the status is followed accordingly. Like, if I give a grant, it will show that, yeah, this grant has been given. If someone withdraw that grant, it will also show that this grant has been withdrawn. You get? And also, if you withdraw your grant partly, you don't want to withdraw everything, the NM also shows you that it is partly withdrawn. Now we have a struct. Right, we have a struct. Like I talked about struct in last week review. So this struct now is just literally holding this data of different types. We have a unit amount allocated, we have the unit time, because I'm creating a grant and people can only withdraw when the time has elapsed. So clearly, as I'm creating the grant, I also have to add a time. So we have unit time, we have address beneficiary, we also have the status. So to know when has this grant been withdrawn, has this grant been given, has this grant been partly withdrawn. So now we have an event, because I talked about it in our last week review. We talked about events, emitting of events to the front end, so that the users can know what is really going on. So just a way of tracking your changes, you understand? We know like events. Then if you look at over here, what's happening here is that I'm saying that the data type uHint ID is equals to 1, and I'm also saying here now that uHint, which is an array, is set to ID So what is really happening here is that I'm trying to create an array, and I'm making sure that the array will start from 1. You get? I'm making sure that the array will start from 1. So now, why I'm doing this is that I want to track the ID of the beneficiaries that will be added for the grants. You get? So the uint serves as an ID. Then we now have a mapping for this uint pointing to beneficiary properties. Mapping is key value pair type. So we have a uint, which is serve as a ID, and it's pointing to beneficiary properties, and we made it public, beneficiary properties underscore benefit. So this is the name of the mapping, underscore beneficiary properties. Now we have an only owner modifier. So what is modifier? Modifier is a way of limiting access to some certain conditions, to some setting, to other people, and only giving that access to one person. It's also a way of adding conditions and saying, okay, a way of restricting access here to other people and giving it to just one person. That's just the purpose of modifier. It has other use cases. Really, it does. In this modifier, in this only owner, I could add arguments and the likes. So it has other use cases, but for now, in this context, this is what we are using it for. We are just saying that require that the message of sender must be equals to the owner. If it's no owner, it shall return not the owner. So this require is a condition that it must occur. It must make sure you meet up to this condition. If it doesn't meet up, it will say not owner, and it will keep going like that again. Just like if someone else is trying to access my contract and is not the owner, sure, why now? It will just revert. It won't work. Now we now have the time elapsed modifier. Yes, because we definitely want to, when a user wants to withdraw, the time elapsed modifier will be added to that function so that it can check the time if it has really elapsed. Take note, in Solidity we have blog.timestamp and we have what we call epoch time. I would probably explain epoch time, how it works later on, so I won't take much time in this video. Then we now have, now we have a modifier called as time elapsed. And the arguments, remember I said modifier, we can also add arguments. Now we have an argument, data type uint set to ID. Now memory is used to reduce the gas since we are only reading from storage. So right now we just want to read from storage. We are not trying to change anything. We are not trying to write. You understand? So we are just reading from storage. So beneficiary properties, the data location will be memory. Then this BP, what this BP is just like a pointer to this memory. Now is now equals to underscore beneficiary, which is the mapping, name of the mapping. And we now have an array underscore ID, which is this array here, underscore ID. You get? So now what we are now doing here is that we are requiring that bp.time, which is pointing, which is a reference to the storage, which is trying to just read from the storage. bp.time, you notice that in our struct we have time. So now we are now saying, okay, bp.time should be greater than equals to block.timestamp. If it is not, then the time hasn't reached. Like when you are trying to withdraw and the time it's not greater, then the time hasn't reached. Yeah. So now we now have a constructor. Fine, we have said address name is equals to is owner, right? Now in a smart contract, when you're writing a smart contract, fine, you have your state variables. You also have a constructor. Constructor runs once when the contract is deployed, and whatever is in the constructor is implemented. So now in this constructor, we are saying owner is equals to message of sender. You get? Message of sender is a global variable in Solidity. It's just like the global variable that Solidity will understand that, okay, message of sender is the owner, is the address that is deploying this contract. Now, this function now, fine, we want to now create a grant. I'm a kind person. I want to create a grant for people. I want to help people. Now I have a function, create grants. In this function, I have two parameters. Address underscore beneficiary, which is me, myself, which is the okay. So the so I have two parameters, which is the address of the person I want to create a grant for, then the time I want to add that, okay, this is the time I'm creating this grant for this person, and when this person wants to withdraw, if that time have not elapsed, that person cannot withdraw. Value will be added, money, you have to use the money to create a grant. And I'm saying only owner. In other words, I'm the only one that have access to this function. Then it returns you hint, which is the value you are going to add for the, which is the value you are going to, which is the you hint, which is ID, exactly, because you hint, which is the ID. Then we are not also requiring that if message of value is less than 0 hater not allowed. So I'm telling myself that if I want to create a grant for somebody and I'm not adding any value, I'm not putting any money, it should return to me that 0 hater not allowed, because sometimes I might forget when I'm trying to create a grant and I might not add amount. So it will tell me that 0 hater not allowed. Then I will have to rethink and add the amount. So this is required. This is the purpose of require. Very useful actually. Then we now have beneficiary properties. Now if you notice now, we are not using memory again. Why are we not using memory? We don't just want to read from the storage. We actually want to collect. We want to update. We want to read. We want to write. You get. So now this beneficiary properties is the name of the struct, right? And in the struct we have all these values here. So we now have beneficiary properties, location storage, pointer BP equals to underscore beneficiary properties ID. So now this is a dynamic array. You get. We are not putting any size. It's not a fixed size array. So it's a dynamic array because we can just return everything from that storage. We can push to it. We can add. You get. So we now have underscore beneficiary properties. Underscore beneficiary properties ID, which is this underscore beneficiary properties is actually the name of the mapping, exactly, which is you into beneficiary properties. Good. Now we now have bp.amount allocated. This amount allocated is also in the struct amount allocated, which is the money I'm allocating to the person I'm creating grant for. You get. So now we have bp.amount allocated is equals to the message of value, which is the money I'll put. Then bp.beneficiary is equals to underscore beneficiary, which is the person that I want to create a grant for. Then the time, which is underscore time plus block.timestamp. Now, so all said and done, I've been talking about this contract, the logic and everything. So I'm very sure that you are looking forward to seeing how it really works. So I'm just going to do I'm just going to deploy it and just text it immediately for you to see how it works. Compiling, the remix, when you write your contract you have to compile it. So it has been compiled and you see we have our API and bytecode. So I'll go to this guy here, then we can deploy. Voila, I have deployed these contracts and we have our view function, and we have our do now is to create a grant for someone. Let's say I just want to give this, just to make life good for this person. So I'll create a grant for this guy here. Let me copy his address. Copy. Then I'll go back to the address I used to deploy, because if I'm on, let me just be on that same address, right? And let me try to create a grant, and you will now see that might require statements and making sure that it is the owner that have access to this is working. I will try to now create this guy now and create a grant for this guy. So this is his address. Then the time, I'll go to epoch time and copy. Let me add extra 4 minutes, so which is 17, 18, 19, 20, 21, which is 21. Then I'll copy this guy as his timestamp, which is 4 minutes. Come back here and add it here. Then transact. We definitely have an error. And what is the error saying? It is saying not owner. So this address trying to do this is not the owner. You get that? So I'm not going to return back to the owner now. The person will get contracts, which is me. I'm back. Now I can run this transaction to create a grant for this guy. Transact. Okay, 0 return not allowed. Exactly. I did a required statement for myself that as I'm creating a grant, I should add a value, because I'm creating a grant for someone. I have to put the money I want to use to create a grant for the person. So I'm going to add a value now. So everything is actually working as it should. So put the value. Put like okay, based on say I like this guy, I'll just give him 20 now. So transact success. Voila, success. Let me check what's in here. So yes, address, beneficiary, the time, yes, and decoded outputs unit 52 from the ID. Okay, so I created a grant for this person, right? Everything is here. So this person now clearly has been added to our mapping and also has been added to the array as number 2, because the array is starting from 1. So this person is on position 2. So now this person I just created a grant for now. Let's see he not get patient now. He just want already withdraw now. He just want already withdraw now. Then the person will come and say he wants to withdraw. Then the person will add this ID. This person I created for is on position 2. So it should be index 1, because it's the array starts from 1. I created this person is on number 2. So the person's index is number 1. So transact. So it says time never reached, which is what I added as the error. Like if you are trying to withdraw and the time has not reached, it should say time never reached. It's working. So like based on this guy just won't rush withdraw, I don't vex for him already. So I want to reverse the grant what I do for him. So I'll click on this guy. I'll put his own index to again. Number 1, transact. Successful. So I have reversed the grant for this guy. Successful. Then if I get balance for myself, I see that there is no balance because I already reversed this grant for this person. So there is no balance again. Exactly. So it's basically much everything. I can let me create this grant for this guy again. Okay, is everything not allowed? I want to create the grant for this person again to test other functions because I don't want to waste much time to create it. Then get beneficiary info, which is number 1. Call. So now this is the person's details. You see, it got the info of the person, and this is the address. Exactly, and this is the number, which is the grant I created for him. Exactly. Now if I get balance now, the balance is showing. This is the grant I've created for that person. You get. Then this get of beneficiary details. I won't need it now because I've not created so many people for grant. Created many grant for people. I can still call it though. I can still call it. It should still give me just this one info, but just like waste of time because I don't have so much people. If there's so much people I've created grant for, there's when I'll just click on this one to just get all of them at once. You get. So that's pretty much everything. I've already set time, so I cannot test the withdraw on. The withdraw on is working, but if that time has elapsed, then yes, the person can withdraw. But that's pretty much everything for now. Thanks so much for your time. Stay tuned for next week's review.